Welcome to this video lecture on probability. Probability is about measuring uncertainty. Now, uncertainty is everywhere. Tossing a coin, rolling a die, shuffling cards and drawing them from a deck, and more complicated games like horse racing or team sports, but also everyday professional activities like business processes. Will that customer buy that product? Or manufacturing processes. We try to put 500 grams of pasta in a bag. Do we actually put 500 grams in that bag? So in all sorts of processes, there's uncertainty present. And probability gives us a way to describe and measure and predict what's going on in these processes. Let's begin with a simple experiment. If I toss a coin, it's called a random experiment. I don't know what's going to happen. So tossing the coin is called a trial. I'm providing an opportunity for some outcome to arise. Will it be heads? I don't know. So I tossed the coin and I didn't get heads. Okay, so there's uncertainty. And so probability is a way of measuring this uncertainty and dealing with it. Now, there are two ways we can describe probability. We can say that probability means how often does the event occur. So when I talk about obtaining heads on a coin, the probability of heads is 1/2, meaning that half the time the event will occur. So probability measures how often the event can occur. And for that reason, a probability cannot be bigger than 100%, or 1, because an event cannot occur more often than all the time. And in the same way, a probability cannot be less than 0, because an event cannot occur less often than none of the time. So that's our first definition of probability. How often will it happen? If I toss the coin many times, how often will heads arise? There's a second way to define probability, and that is how likely. If I'm going to toss the coin not many times, but just once, will I obtain heads? Yes or no? It's uncertain. But the probability is 1/2. But this time the probability is a measure of how likely is the event to occur on a single future trial. It's either going to happen or it's not going to happen. It didn't happen. Okay, so how likely is a different way to think about probability. We're only trying something once. So if the probability is 100%, it means we are certain that the event will occur. If the probability is 0, we are certain that the event will not occur. If the probability is close to 1, close to 100%, then we are confident that the event will occur. If the event is close to 0, then that would be significant. That's an event that we do not expect to occur. And so we use these concepts a good deal in statistics because we often wish to make statements with confidence, which means we have a high probability that the statement is correct. We also use the idea of significance. Something that's unexpected or rare happens. Maybe it happened for a reason. And so that can also tell us something. And so within estimation and hypothesis testing, we use these concepts a great deal. So let's talk about how we measure probability. We've already said that the probability of obtaining heads on a coin is 1/2. That sounds reasonable. There are two sides on the coin, so there are two possible outcomes. Only one of those is a head. So 1/2, a half, is the probability of heads. And this is true because the coin is similar in that both sides, both outcomes are equally likely. A second way of measuring probability has to do with events where the outcomes are not equally likely. If I sit into my car and turn the key, I expect the engine to start. Usually it does. But it's not 1/2. It's not half the time. How can I measure the probability? Well, I can try that event many, many times. And having done it thousands of times over recent years, I can estimate that event as the probability the car will start is like 99.99%. There may be an occasion where there's a flat battery or something else, but the only way to find out is by gathering data. I cannot just, as with the coin, I cannot just figure it out mentally. I have to gather data. So saying that the coin it's 1/2, that's called classical probability. But having to try out my car many times, that's called empirical probability. And there's a third way of measuring probability. Let's say Ireland are playing some team event next weekend. Will Ireland win that event? We can't say it's 1/2 because the Irish team, of course, is probably a good deal better than the other team. We can't say, let's do it many times. That's not possible. All we can do is make an assessment, make a guess, an educated guess, and say, well, I think the Irish team are stronger, so I think the probability of success is 80%. And that kind of approach can be used in betting, where rather than the probability, the word odds is often used. So 80% probability is 80-20 or 4-1. Now, we often want to combine probabilities, and there are 3 words we use to combine them. The first word is the word not. If the probability of an event is 80%, then the probability that the event does not occur is 1 minus 80%, that is 20%. 1 minus 0.8 is 0.2. So 1 minus the probability of an event is the probability that the event does not occur. So the word not is very useful. Very often it's easier to calculate the probability that an event does not occur and then subtract the result from 1 to give the probability that it does occur. Another word we sometimes like to use is the word and. Let's say a game consists of tossing a coin and rolling a die, and we require heads on the coin and 6 on the die. The probability of heads is 1/2. The probability of a 6 is 1/6. The probability of heads and 6 is 1/2 times 1/6, which is 1/12. So the word and suggests that we should multiply the probabilities, provided, of course, that the 2 events concerned are independent. That is to say, when heads occurs on the coin, that does not change in any way the probability of a 6 arising on the die. Another word we like to use when combining probabilities is the word or. Let's say we roll a die and we're interested in getting either a 6 or an uneven number. The probability of 6 is 1/6. The probability of an uneven number is 3/6. The probability of getting a 6 or an uneven number is 1/6 plus 3/6, which is 4/6. So the word or suggests addition, provided that the events are mutually exclusive. That is, the uneven numbers do not include the number 6, and the number 6 does not include any of the uneven numbers. So when we have mutually exclusive events, we can find the probability of one or other event using addition. So our 3 rules for combining probabilities are not, which is 1 minus, and that applies to all events, and, which suggests multiplication, and that only applies to independent events, and or, which suggests addition, and that applies only to mutually exclusive events. You can read more about this in the textbook in section 2A.